Welcome and thank you for standing by. I would like to inform all participants that your lines have been placed on a listen-only mode until the question and answer session of today's call. Today's call is being recorded. If anyone has any objections, you may disconnect at this time. I would now like to turn the call over to Catherine Hambleton. Thank you. You may begin.
Thank you and good afternoon. I'm Catherine Hambleton with NASA's Office of Communications. Teams at NASA's Kennedy Space Center in Florida continue to prepare the Space Launch System rocket and Orion spacecraft to return to Launch Pad 39B to complete the wet dress rehearsal activities ahead of the uncrewed Artemis 1 lunar mission. The rehearsal is the final test needed before launch and calls for NASA to practice the timelines and procedures to load cryogenic or super cold propellants into the rocket's tanks, conduct a full launch countdown, and also drain the tanks. Here to talk with us about the recent work in the vehicle assembly building and the path to get back to the pad are Tom Whitmeyer, Deputy Associate Administrator for Common Exploration Systems Development at NASA headquarters, Cliff Lanham, Senior Vehicle Operations Manager for Exploration Ground Systems Program at NASA's Kennedy Space Center, and John Blevins, Chief Engineer for the Space Launch System Program at NASA's Marshall Space Flight Center. We'll start with opening comments from Tom Whitmeyer and Cliff Lanham, and then Tom, Cliff, and John will take your questions. You can enter *1 on your phone to be entered into the question queue at any time. Again, your phones are on mute now, and the operator will open your mic when we're ready and close your mic after you ask your question. Shortly after we conclude, you can listen to a replay of this teleconference online. First, we'll hear from Tom Whitmeyer. Tom?
Thank you, Catherine. First of all, I wanted to thank everybody for joining us today. I know it's getting ready for the Memorial Day weekend, and we appreciate your dialing in, and hopefully we'll be able to give you a good update today. I'll talk a little bit up front. Cliff will get through most of the detailed specifics in terms of the role and what was accomplished in the VAB. Of course, Dr. Blevins is here to ask any specific technical questions you might have. And then when we get to the role, we'll have another get-together, and this time we'll get Charlie up here, and she'll talk to the actual specific exercise that we'll go through as we go through wet dress rehearsal. So if you have really detailed questions in that area, Charlie will be available in a couple weeks, and she can answer your questions then. Let me just add, Jim had a chance to come update you last time, and I just want to reinforce some of the things Jim said in terms of this is a very complicated process. So we have a very robust vehicle, a great design, but the actual and the vehicle itself is a very straightforward vehicle. But anytime you get into loading operations with cryogenics, it's something that you have to kind of take a step at a time and learn through the process, how the hardware is behaving, as well as the rocket. The rocket itself is doing very good. All the things that we've seen so far have been very positive in terms of the actual performance of the hardware, but we are still working through some of our processing. And I think Jim mentioned it last time. We'll actually add a little schedule this time around just to make sure if we have to do more than one wet dress rehearsal attempt, that we're ready to support that. And so I'm going to let Cliff get into the specifics. He'll talk about the check valve. We'll talk about the umbilical work that we've done. We've got some GN2, robust GN2 system now that's really been upgraded, and we're very happy for that. And then also, Dr. Blevins is here in case you have any specific questions. With that, Cliff, I'm just going to turn it over to you.
Okay, thank you, Tom, and hello, everyone. Let's see, since we last spoke, teams have been hard at work preparing the Space Launch System rocket and the Orion spacecraft to return back to Pad 39B. We're planning for that to occur on June 6th in preparation for our next wet dress rehearsal. Teams have performed several leak checks to address the liquid hydrogen leak that was found on the tail service mast umbilical between the mobile launcher and the rocket during the previous wet dress rehearsal attempt. As we mentioned in our previous teleconference, we noticed the flange bolts on the tail service mast umbilical had loosened over time. So we went in there and retightened the bolts on the flanges and conducted several leak tests and observed the system and ensured they did not loosen back up. And all looks good there. After replacing, so we'll move on here. After replacing the helium check valve and other hardware located on the interim cryogenic propulsion stage, we tested it to ensure it functioned properly. And so far, we've had no issues with the new hardware. We have also modified the ICPS, again, the second stage umbilical boots. which is the area enclosing the umbilical quick disconnect between the umbilical arm and the vehicle. And we're adding additional leak detectors on the liquid hydrogen side of that in order to gain some visibility into any potential leaks that would occur during tanking operations. This modification also allowed us to complete some of the forward work that we had originally scheduled to take place in the VAB after a wet dress rehearsal. So some of the work we've completed in that area for the Orion crew module, we opened up the hatch and we installed part of some of the payloads. The BioX-1 space biology experiment, we got the containers that will actually hold the experiment installed. We've also worked on several external areas of the crew or the Orion in terms of we put on the plates that the last plates that where instrumentation was running through for the rollout. We took those off the GSE plates, the ground system plates, and we went ahead and put the flight plates on. And that'll give us additional protection when we roll out from the weather and the environment. And then we also removed much of the instrumentation that was on for the dynamic rollout test, as well as we've been working on core stage TPS. We did some leak checks on the pneumatic actuation separation system for ICPS, and we changed out some instrumentation inside the boosters. So meanwhile, while our team has been working inside the VAB out at the launch pad, we also tested the new upgrades to the gaseous nitrogen supplier that supplies us nitrogen during the propellant loading. Overall, the testing was successful, and we should be in good shape for wet dress and are currently targeting call to stations on the evening of June 5th. Actually, let me back up here. So that test went well. And now I'll talk more specifically to the dates here. So right now, again, we are looking at call to stations for the rollout to the pad on June the 5th. Call to stations is expected to be around 6 p.m. With first motion around midnight on June the 6th. We were going later in the evening because with the weather in Florida in the June timeframe, it's much less likely to have thunderstorms in that time. What this does, this will put our WDR flow, cryo flow, no earlier than the 19th of June. We have built in 2 weather days that could move that date around slightly. Again, it is Florida in June, so thunderstorms are expected. And we will also be working any range constraints that may come up. So again, looking at no earlier than cryo flow of June the 19th. Also, we are wrapping up the work. We are finishing up a few items in there, but we do expect to start retracting the platforms next week in anticipation of rollout to the pad. And that's all for me. Thank you.
Thank you, Cliff. All right, so now we'll begin the question and answer portion. Again, you can enter *1 on your phone to be entered into the queue at any time, and you can enter *2 if you'd like to be removed from the queue. We ask that you please stick to one question and identify to whom your question is directed. If we have time, we'll allow reporters to ask a second question. All right, so first we will go to Marcia Dunn of AP.
Oh, yes, hi. Probably for Cliff, although I'm not sure. You mentioned in case you have to do more than one more wet dress, what kind of things would happen in the June 19th or whenever fueling test that would prompt you to want to redo it? Assuming you've got all these latest problems fixed, what else could require a second wet dress? Thanks.
Marcia, this is Tom. Let me start with, and then I'll let Cliff follow up on that. And when next time up, we'll have Charlie here, and she'll be even more articulate than either Cliff and I could be. But one of the things we're really trying to do is we want to show the dual cryo load. So we want to load the core stage, and then we want to load the upper stage and verify all the new procedures are working the way we think they should work. And then we want to get down into the count, and we're specifically looking at a GLS, ground launch sequencer, to ALS transition point. And so we'd really like to get to that transition and show that we're able to hand off from the ground to the vehicle where it takes control. And so that would be the thing, if for whatever reason we're not able to get to that point in the countdown, that we would want to take another look to see if it made sense to do another attempt or not. And it's very situationally dependent. It depends on how much of the activities we can get through, but we really would like to demonstrate the dual cryo loading, and we would like to try to get down on the count. And Cliff, is there anything you'd like to add to that, or?
I think you covered it, Tom. Again, getting cryos up into the second stage as well will be important, and we're looking forward to getting that done. But I think you covered it. Thanks.
Thank you. Our next question is from Bill Harwood of CBS News.
Yeah, hey, thanks, guys. This may be for Dr. Blevins. Can you talk a little bit more about the confidence level you have in fixing the LH2 leak? I mean, I'm asking that because we were going back today thinking about, trouble with the shuttle's, ground umbilical plate back in 2009, where you had 2 flows out of 3 that got, sidelined by cryo leaks that you really couldn't confirm until you flowed cryo. Is it the same case here, or is there something that makes you think you really have fixed it this time? Thanks.
Hey, Bill, that's a really good question. First of all, you are correct to say that you cannot confirm the leak until you do flow cryos, right? That's a different condition. We don't do that in the VAB. But let me tell you why we do have confidence, and I think there's good confidence among the ground team as well as I have confidence in what they've done. These seals that they use, and you heard Cliff mention the seals and tightening it down, and he talked about rechecking those seals. Those seals age with time, and so what had happened is we had tightened those down previously, and we hadn't done really a series of torque checks over the period of time that we found now that those seals age. I think that's really a good way to put it, is we age those seals to prevent leakage. And so we have good confidence that we've done the right process, and you're correct to say that we'll have to verify that when we get out to the pad and flow the cryos. Now, there is one good mitigating circumstance in the event that it's not a 100% solution, and that is we can't access those at the pad. So any additional mitigation can be performed at the pad. But I do have good confidence that we've got the right process. Will it have to be tweaked? That's a possibility, and we'll find out pretty shortly.
All right. Thank you. Our next question is from Jeff Faust of Space News.
Hey, good afternoon. Question probably for Cliff. I'm curious, with the get-ahead work that you were able to do while you were back in the VAB, how much time in terms of the schedule that saved you? And also, are you able to do anything with the in terms of servicing those CubeSat secondary payloads? They need, for example, their batteries topped off or anything like that? Thanks.
Yeah, thanks for the question. From the work standpoint, well, let me talk to CubeSat real quick. We do have the capability to recharge several of the small CubeSats, and we have done that previously. So that is complete. And then for the previous question, we have, in terms of the work and the schedule that we've completed outside of the known issues that we came back to fix, we have done a lot of work that is primarily, it'll really help us from a standpoint of the volume of work. That's the best way I can put it. It's not necessarily critical path work that we were able to perform, but we were able to get a significant amount of other work, I'll call it. And we did run into some nonconformances with that work that would have cost us time later. So that's very beneficial for when we come back. And then also from a resource standpoint, it allows us to lessen the demand on our resources when we do get back into VAB, and what I feel is lessen the risk on our overall schedule for rolling back out for launch.
Thank you. Our next question is from Eric Berger of Ars Technica.
Hi, thanks for doing this, and I hope you all have a great Memorial Day weekend as well. I think this is a question for Tom. Can you talk about any concerns that you're tracking with the hardware, as this launch slips further into summer or fall or beyond? I know you've been monitoring the boosters, and I think you're pretty confident in the lifetime of those, but maybe other systems as well. I guess what I'm wondering is there a date when you need to launch by before you might have to start thinking pretty seriously about destacking components of the rocket? Thank you.
Hey, Eric, that's a great question. First of all, right now, everything we've looked at in the foreseeable future, we're not tracking any limited life items that would cause us a concern. And I'll ask Dr. Blevins to add to this, so I'll give you a good answer. As we proceed into the year, depending on what we see, and what we typically would do, the process that we normally follow, and we did this throughout the shuttle program, is if we identify something that's beginning to get close to one of our limited life areas, and that would be in the late fall time frame, we evaluate it on a case-by-case basis, and each of the items have specific approaches that we look at. With the boosters, we have testing that we've done to see if the propellant's sagging, if we have any concerns there. There's a little strap that holds the arrays on Orion, and we would take another look at that to make sure that the Kevlar strap is qualified for a longer period of time. So, I don't really foresee anything that we would have a concern with, or a stop the clock thing. And what we would normally do is just follow our typical procedure, which is if we do extend into that period of time, we would definitely, keep checking. We have a very accurate list. We keep track of all the environments that the hardware is seeing, and then we would evaluate it. And most times it's just a matter of sharpening your pencil. You don't want to do all that up front if you don't think you need it. As you get closer and later into the year, we would go back and do that. And John, do you have anything to add to that?
Well, Tom, I think you covered most of it really well there. We do track all of the limited life items, Eric. The soft goods are really the major concern as you go through that. I know you mentioned booster stack life. That's also a concern, but all of it's data driven. That's really what we do. Right now, what we do is we track those to a margin. So usually we have multiple lives that we're tracking to, and so we know when we eat into that. You do bring up a really good point that sometimes as we try to perfect one system, you can add risk to another by trying to make one perfect and add, stack life or other age life. So we track not just the life-limited calendar time, Eric, but we also track the usage, right? So how many cycles we put on the tanks or any other thing. And so we're tracking all that well. And as Tom said, there's nothing really in the foreseeable future with our anticipated usage or calendar time that prevents, or merits any immediate attention over the next several months beyond our intended flight date.
Thank you. Our next question is from Philip Sloss of NASA Spaceflight.
Thanks. I'm not sure if this is for Dr. Blevins or Cliff or maybe even Mr. Whitmeyer. I wanted to just get a little bit of detail about you were looking into a root cause for the rubber quick disconnect seal failing, and also any root cause for the aft purge boot leak, and what you're doing going forward on those. Thanks.
Hey, John, why don't you start? I think that this would be a good one for you to start on.
Yeah, I think so too, Tom. I've been involved in some of this. I think Philip's referring to two different systems. When he said the rubber seal, I think he's talking about specifically talking about the butane seal on the ground side, QD on the helium-filled system. There's two systems that we're looking at, and Cliff mentioned them as we started up. And one of them is the helium-filled system. That's the one we'll talk about with a check valve. And we talked about that check valve last time. So let me just cover a few things there because I know there's been a lot of talk. One is the check valve was just fine. We did ingest a small piece of debris that held the check valve open. That's why it didn't pass the reverse flow check. And so that check valve actually was then tested to our acceptance criteria, and it passed that acceptance criteria. It was sacrificed, to essentially investigation, destructive evaluation, just to take a look at it. To add to our database, but ultimately there was no problem with the check valve. We did have an issue there on that quick disconnect, and we had a rubber seal, if you will, that had been dislodged. We do have a fault tree. We're working through that fault tree. There are several suspect items. All of those are under mitigation, if you will, or will be under mitigation. We want to look really hard at that and not jump to conclusions. So on that particular one with the helium fill system, I feel very confident in the system we have today because we X-rayed it. We did stacked X-rays or CT scans to take a look that it's in the design configuration, and it indeed is. When you mentioned the boot, and we have worked on the boot, and I'm glad that somebody brought that up because I think there's some misunderstanding on the boot. What we saw a little bit of air being sucked into the HAZGAS system from that boot. That boot is just a push fit, so kind of a pressure seal there. And of course, this is a case where we've talked before, there's a difference between ambient checking and cryogenic checking. And so we check to see if that boot sucks in any air, if it leaks helium out as we purge that with warm helium over those QDs around that boot to prevent icing, as well as other situations. And particularly for the hydrogen, we prevent a flammability situation. And so what we're doing there is we don't want a false measure of flammability. Any contaminant, even if it's air, it shows up in our HAZGAS system as potential hydrogen, and we've got a 4% limit on that. And of course, if you're putting helium in and you suck air into that boot, helium and air don't burn, and so we don't want a false alarm. And so what we're doing there is we're adding some measurements where we'll take that to a mass spec for the ground side. Very innovative by our EGS team to do that and move it over to a mass spec that they can use and then differentiate between that air and hydrogen so that we don't falsely shut down the tanking of the system due to a false alarm. I think that kind of answers the question that Philip was asking there, Tom, but you can certainly add more. You've been part of this discussion as well.
Yeah, we were actually just talking this earlier today, and we're going through a board, and we think we're ready to go to wet dress, and we've cleared it for that. We'll take and finish up the root cause for the check valve, and the check valve, to John's point, just performed great. We just had a little piece of rubber, and we're going to need to make sure. Right now the system's clean, everything's ready to go. I did think of when Bill brought up the thing earlier about the guppa leaks, and we were all there. I was on the shuttle program for that. And one of the things that we are doing for the boot is actually putting an external monitor out, and that's kind of a similar thing that we did back in 2009. So I think that will really help. We think we're getting good purge in that area. We think that we're just getting false trips, but we'll having an extra set of data to take a look at will help us verify that that's the condition that we're looking at. And boy, I really wish I had a picture of this thing to show you. It doesn't really make a lot of sense. We actually were visiting Florida the other day, and they took us over and showed us the QD, showed us the boot, showed us how it all comes together, and it really makes a lot more sense when you can kind of see it. But I think I agree with Dr. Blevins, and Cliff, I think, would say the same thing, that we think they've done a good job taking a look at it. They've put some mitigations in place and some additional monitoring in place, and hopefully that will address the condition we saw during the last test. And Cliff, you have anything else to that? That's kind of how I'd summarize it.
Yeah, Tom, the only thing I would add is we're in process of putting those fixes in place right now, and we anticipate that being fully ready to go well ahead of our rollout.
All right, thank you. Our next question is from Stephen Young of Spaceflight Now.
Hi, yes, I think this is a question for Dr. Blevins or perhaps Cliff. I wanted to get a better understanding of the sequence of events leading up to the hydrogen leak during the last WDR attempt. Hoping you can tell us how many times did you actually start the hydrogen fast fill? When was the HAZGAS detection triggered? What was the maximum concentration? And how far above the limits was that? And also, we got Twitter updates that described a surge of hydrogen during the transition to fast fill. It sounds like geysering, but I didn't think that was a thing with hydrogen, and I'm hoping you can also explain that.
Well, I guess I can, this is John Blevins. I guess I'll take the first stab, Stephen, at some of your questions there. As far as the sequence of events that occurred for the hydrogen fill, and I was, sitting there on console, it's been a little while, so you'll have to forgive any memory losses here. But, we had a constraint. We still have the constraint for this initial full tanking for the aft strut, and so we stopped the oxygen tanking at roughly 49%. We have a 50% limit that we don't want to tank to just because of the load. We don't want that load on that aft strut until we start contracting the hydrogen tank, if you will, due to its initial temperature. And so we did actually get some good data on that, by the way. And then so we had done the slow fill and got to that point of fast fill, which is roughly that 5% full wet sensors. And immediately upon the fast fill, we detected the hydrogen leak, so it wasn't very far into that. I do not recall recycling to do it again, but I would have to look at my very specific notes. There's a lot of different responsibilities on launch day, and mine is mainly to monitor the vehicle and make sure it's performing well. I was sitting with the ground system chief engineers, and we were all talking together. So I don't recall a second attempt, but Cliff or Tom may be able to correct me on that. But as far as your question about when it was detected, that was pretty much right away during the fast fill time. As far as the geysering question, I'll skip to that comment. Not really a thing for hydrogen. And as far as what you probably heard is that it was warm. The hydrogen, due to buoyancy, will accumulate hydrogen. And so when we changed from slow fill to fast fill, what we had is we had some lines that were vertical lines. And since those vertical lines weren't bled per se, when we started that, you suck in that warm amount of hydrogen. And so that's probably what you heard, but it's not the same as an oxygen line where you would have, say, warm propellant in a feed line that might traverse that feed line and cause a geysering issue. So it's certainly not the same, but that's probably what you heard. We have corrected our loading ops to a point where we think that both the oxygen and the hydrogen, as far as accumulation of warm propellant, is mitigated. So I think that answered two of your three comments and questions, and I think Cliff may have the other one.
No, John, we would have to get back. I was not on console that day, so I don't want to speak to the exact chain of events there.
Yeah, I actually have a phone a friend here with me, our mission manager, Mike Seraphin. Mike, how did you describe it?
Yeah, so John Blevins is absolutely right that when we transitioned from the chill down and slow fill to fast fill, we did see an increase in pressure. So it may have been initially called or characterized as a pressure spike when we went from the slow to the fast fill. When that happened, we did see a hydrogen leak, and it did hit our concentration limit constraint, which is 4%. Within the confined space that we measure, the team stopped the flow and assessed the data, and then decided to try again a second time. And when they tried again the second time, they essentially got the same result. They saw the pressure increase when they went to fast fill. We saw a leak as detected by the hazardous gas system, the HAZ gas system, that hit our concentration limit, and that's at the point where we decided to knock it off. So they did try twice during the final attempt, and that essentially confirmed that we had some work to do there on that umbilical.
Yeah, Mike and I had a chance to visit Cliff a couple of weeks ago. We got a tour of the whole thing, and this is another one. It's kind of like the boot. If you could see it, it'd be a lot easier to understand it. He did a fantastic job of showing us where the cryogenics come into the ML. We have what we call skids. Skids are a fancy term we use at NASA. They're pallets where we keep the valves that open and close that allow the cryo to flow. And there's two skids, one for the core stage, and then there's a second skid for the upper stage, and it's in a different location. And so it's a big Y, and it goes to two skids. And when we change the pump speed, it actually pulls up some of that cryo that's been kind of warming up and pulls it into the system. And LOX is different than hydrogen. LOX is dense. It's like the density of water. So we pump it from a pump that's actually at the pad, and we pump it through the system, and we worry about geysering, which we discussed before. Hydrogen wants to flow. It actually doesn't require a pump. It's a pressure managed system. And the thing you got to work out for hydrogen is you have to bleed it off and get that temperature down. So these folks have done a tremendous job of looking at the system, where the skids are located, lubricated, what this pump speed regulation needs to be, how, we worry about geysering with locks because we go up the downcomers to get to the core stage. And also we worry about pressure with hydrogen. It'll heat up, and therefore we have worked our way out of having high point bleed so that we can get the temperature down with the hydrogen. So I think that's all really complicated stuff. Once we get this dialed in, as they say, we'll actually have a really successful loading operation. Sometimes you just have to learn these things as you go through the process because it's really cold stuff that we're flowing, and it will change state on you pretty quickly if you're not moving it in the precise right fashion. So that's kind of how I would describe it. I think each one of us would probably describe it a little bit different. Cliff, you have any thoughts on that one? That's kind of my thought on how to describe it.
Yep, you hit it, Tom. Right on.
Yeah, I have the benefit of actually getting to join these folks and Dr. Blevins and Cliff and Charlie, and we go down and we will walk through the whole thing and look at the hardware and follow the lines and see where the cryo's flowing and look at the skids and stuff. So, I wish we could take you all along for one of those tours because it just makes this stuff a lot easier to understand. But, I think they've got a pretty good plan in place. We'll see how it turns out as we get into our next attempt. But I certainly think we've learned a lot and figured out a lot of specific things and how you want to do this dance and checked off a lot of steps, but we really need to get back into the flow and the loading operations to see if we figured everything out, and if we don't, we'll have to spend another opportunity to verify it. Dr. Blevins, anything else on that? That's kind of my...
No, I think that's a great summary, and I'm looking forward to getting back out there and trying it again.
Yeah, I think for us, we really, really want it. We're really, actually kind of a little bit excited to have an opportunity to take this knowledge that we have now and give it and put it into the system with the updated procedures. Many of them have been put into software, and we're really generally very interested and hopefully this will go well, but we also recognize we still could be missing something, so we'll find out here shortly.
All right, thank you. Our next question is from Mark Carreau of Aviation Week.
Thank you. I wanted to just double check that the goal is to get down to eventually the L minus 9.3 second point with a count to 33 seconds and then a go back to I think 3 for a 10-minute hold. Is that still how close you want to get to an actual launch?
Yeah, this is Tom, and that's correct, Mark. And Charlie we'll have Charlie back up here for the next go around, and she'll walk you through all the procedures and what the countdowns will look like, and also the rest of the activity. But that, Mark, you got it right, and we will have Charlie here next time, and she'll go through a really detailed description for you guys once we get a little bit closer to the wet dress.
Thank you very much.
And Mark, we've got the countdown timeline as well as the differences between the launch countdown and the wet dress countdown. Those are online if you need to reference those for those specific points where we'll stop on each run and recycle. All right, our next question is from Josh Dinner of Space.com.
Hi, thanks so much. This question is for Cliff. If everything goes well during the June wet dress rehearsal, is there a specific window, or I guess window hopeful perhaps, of one of the ones that have been outlined through this year and next? Is there a specific one of those that's being targeted for the launch right now?
I'll help Cliff off on that one, and then he can add if I'm missing anything. First of all, I think Jim was with you last time, and I know the administrator might have mentioned this as well. So we're looking at an August window is our opportunity, and all those windows have been put online, and Catherine can point you in the right direction so you can go find what the windows look like. Now, of course, we're always very nervous because, as I just mentioned, we've learned a lot so far, and so we really want to get into this cryo load and demonstrate everything, get down to the count, and then we'll set an official date. But I think both the administrator and Jim have kind of identified as the August timeframe as the one that we're currently looking at. But I just want to be really careful. I don't want to sound overly optimistic or mislead you. We really feel like we need to get into this cryo load, do all the things we just described, which are kind of complicated, actually. It's a great vehicle, very simple vehicle, but the actual procedure that you go through with any vehicle of this nature requires fine-tuning. And so that's I think where we're at. Cliff, any additional thoughts to that? I think that's kind of...
No, Tom, again, you covered it. I appreciate that. And, we'll take into account any of the work we just completed, like I mentioned earlier, in that post-WDR timeframe, as well as any concerns or issues we have to deal with coming out of WDR. But like you said, it's too early at this point for us to really forecast that beyond what you said, the August timeframe.
And those launch periods are linked on the Media Resources tab for the Artemis 1 mission on nasa.gov, along with that countdown timeline that I mentioned as well. Our next question is from Jim McDade of 1819 News Huntsville.
Good afternoon. Thank you for answering our questions. I think in the beginning, Mr. Whitmeyer mentioned changing out the GSC plates with flight plates. I'd like to know a little more about that. Is that a procedure that was initially or normally scheduled to be done at the pad? And what went into the decision to go ahead and do that in the VAB, if it was?
Yeah, Jim, I'm trying to remember what I might have said. I might have misspoke. I haven't really changed any plates out. We replaced the check valve that John and Cliff talked to, and that would actually worked. The check valve was actually working okay. We just had a little piece of debris stuck in it. I'm trying to think if there's anything else that I might have mentioned in terms of any off-nominal stuff. I think pretty much everything that we're doing right now is just the work that Cliff described. So I'm trying to think, Cliff. Yeah, go ahead,
Tom,
Cliff.
I might be able to help. This is Cliff. So I mentioned, with the last, we did take off the ground plates that were the instrumentation for dirt was rolling through. So we did change those out to the flight plates, and there was a oxidizer panel plate also that was put on for flight. So what we did, we took the opportunity to go ahead and put some flight plates on, particularly in the Orion area, while we were in the VAB.
Yeah, thank you for saving me, Cliff. I forgot about that. Yes, that was a good question, Jim, and that's what. So it was just kind of an opportunity to get ahead type of thing. Thank you.
All right, thank you. Our next question is from Danielle Regretta from R Drone UI.
Hi, good afternoon. Thank you, all of you for taking my question. This is for a really wide Spanish audience. And this is regarding if you can tell us more about the general state of other stage of the rocket, and if anything else has been done apart of the initial problems you just corrected. Thank you. Have a good day.
Yeah, Daniel, what was the second part of the question again? I just want to make sure I'm answering it correctly.
If anything else has been done apart of these initial problems.
Let me see. Let me see if I can. This is Tom. Let me see if I can help out, and then just repeat your question if I get something. First of all, for the Spanish audience, I can't tell you how proud we are that we have an ESA service module as part of this flight. Anybody who's seen some of the pictures of the rollout and stuff will see the ESA logo on it, and I just want to make sure everybody from the Spanish audience knows how important we think our partnership is and how proud we are to have the ESA capabilities on the vehicle, and that's great. The other thing is I'm being reminded that we have a Deep Space Network facility in Madrid, and and Daniel, I assure you, I'm one of the people who would love to go visit it because I think Spain's a beautiful country, and I would love to be able to see that dish. So that's a really important thing for us, particularly for this mission, because we're going into deep space. So I think everybody in Spain should be very proud of the fact that they're helping us communicate with our vehicle, and when we have the crew fly the next flight, they'll be talking to folks on the Earth coming through the Spanish capability. So we're really excited about that. All of us are really just really happy to have this partnership working together, having all these other countries that are part of this mission. And I really hope that everybody in Spain, when they see this flight and they watch it leave the pad and as it goes into deep space and kind of track it as it goes through, and my mission manager here, Mike Serafin, will be describing that as we get closer, that they feel that they're part of that mission and the things that they do are in space with us, because that's how we feel about it, and we're just really happy to have a partnership. And like I said, Danielle, in fact, I've always kind of argued, I was talking to Tony, that we had Carlos and Tony are two folks that we have that kind of work with us and with the international coordination, and my goal is to have, after the mission's complete, to go visit some of these countries, and I think Spain would be the one I would like to visit the most. So, did I answer your question? I was hoping I got the question right.
Yes, some of the question is about the general state of other stages also of the rocket. If you make plans to correct other things, not explicit on the first Wet Dress Rehearsal.
You know, everything else was looking great. Even the check valve turned out to be a little piece of debris, the check valve. So I always look for an opportunity to say the Mega Moon rocket's doing really good. We really are happy with the performance of the vehicle and the Orion and the service module. We do a lot. What we don't talk about is Cliff and his team are constantly powering the vehicle up, powering it down, checking things. And so we don't really report that progress because it's all going very well. And so we're not seeing anything unusual. The checkouts are going great. The vehicle is in good condition. We've had a couple things that we've described, which I really view as more of a first-time kind of learning exercise on how to move, hydrogen and LOX, which are really actually a tricky thing to do. But when you look at the performance of the vehicle itself, we're in all the stages of the vehicle, including the service module, it's gone very well. And so there really isn't anything else to report outside of the updates that were given. But I would point out that then Cliff can verify this. We spent a lot of time powering the vehicle up and powering it down, and everything else is checking out very well. And I don't know, Cliff, if you had anything you want to add to that, or?
The only thing I would add, Tom, is you're absolutely right again in terms of actually we're powered. We just powered down today the ICPS as we're doing confidence checks to make sure everything is in good shape prior to rolling. And we'll be doing that for the core stage and the boosters on Tuesday. Again, confidence checks now that we buttoned up the vehicle in anticipation of rolling. Again, we're constantly up and down with power. And again, we check everything, make sure it's all functioning properly before we'll roll out.
Thank you. Our next question is from Ken Kramer of Space Up Close.
Oh, hi. Thank you for doing this and telling us all these details. I would like to ask you about the gaseous nitrogen upgrade. If you can go into some much greater detail about, what you've done. I know you did a test. Talk about that, and why are you confident now that you have sufficient capability? Thank you.
Ken, this is Tom. I'll start a little bit on that, and then we'll also talk about the confidence test as well. A company actually provides the service to NASA. It's just off-site. If you go down State Road 3, if you're leaving the KSC side of it and heading down State Road 3, you'll see this company. It's on the right-hand side. It's called Air Liquide. And what they do, and I know more about gases nitrogen now than I thought I ever would. What they do is they take liquid nitrogen, and there's different ways you can gasify the commodity. You can steam generation. Literally, you put it in steam. It looks like a little distiller coil. It heats up that liquid. It turns it into a gas, and that's how you distribute it out. And the second thing you do is you can use air exchangers, and air exchangers are literally what it sounds like, big cooling towers that are up there, and that actually heats up that liquid nitrogen and turns it into the gas. But they had a systems robustness upgrade that they had planned all along that they've just completed, and we've done a test to verify that it's working properly, where they've added these air exchangers in addition to the steam generators that we had before. And so this is really a belts and suspender type of thing. If we have to switch from the steam generator to a air exchanger, they can do that. So we feel very comfortable that it's a robust capability. We require commodities because it's such a big rocket. We require a proportional amount of commodities. We do it to purge the cavities and make sure the umbilicals are nice and dry and things like that. So there's a lot of different functionality on the vehicle that requires gaseous nitrogen, and that's really that this added capacity of the air exchangers is the thing that really, and the ability to switch back and forth is really added some incredible capacity, and we're really happy to have it. In terms of the systems checkout, and off the top of my head, and I think Dr. Blevins will probably have to correct me on this, what we do do is we literally spend a period of time where we're out at the pad, and we basically create a situation where we're using up the commodity at the level that we would need it for wet dress rehearsal. We're not putting it on the vehicle. We're putting it on restrictor plates and everything, so that we're actually pretending as if the vehicle is sitting at the pad consuming all this, the commodity that would be necessary to go through a wet dress rehearsal. And they do it for a long period of time. And that's how they verify that the system's ready to go, that all the pumps are up and running, the ability to switch around is there, and that we'll have a robust capability. Now I'm going to stop there. Dr. Blevins, did you want to add anything to that?
You know, I'll add, as you said, Tom, this is a service. It's critical to us, you know, particularly even after we tank the vehicle while we're evacuating the propellant. In this particular case, or on the day of launch, if there's an aborted launch, it's particularly important because it prevents damage to our avionics by flowing the warm nitrogen into the system and preventing condensation. The way that we feel confident is that we asked for a long-duration test, and that was provided by this service provider. It was a 32-hour test. And every part of the profile of those 32 hours exceeded what we would do in both duration and in volume of nitrogen demand with simulated resistance at the pad or dampers. And so we basically have a witness now that we can get this commodity to exceed the time duration and volume. But it is a very critical commodity, and so that's, of course, why we rolled back. And that one witness that that company did is what we've got to go with. And I'm confident, but I'm also cautious because I need this commodity, or I've got to work real hard to exonerate hardware. You know, if we can't provide the purge. So I'm ready to go based on that one test.
Yeah, and Cliff, I don't know if you want to add anything to that. And
nothing to add, Tom. Again, I'll just, John, I would correct one thing. It was a 34-hour test. I think you had said 32, so just clarify that.
Yeah, I agree with, you know, it was a very robust test. Of course, they use this commodity. They actually support every launch that takes place at the Cape. And so they're up and running. They're supporting every launch activities. Ours is, because it's a more capable rocket, we have a proportional amount of use that we have for the rocket because of its size and scale. And I think they're ready to go. I agree with John, though. We'll monitor the situation, and it's important to have gaseous nitrogen, as it is with every rocket that flies, because of the things that it provides the rocket. And this is not unique to us. It's really every rocket requires this type of purge capability. What's unique to us is that we have a rocket that's designed to go to the moon, and so it's a big rocket, and therefore we have a proportional need for purge relative to the size of the rocket. But I'm very comfortable. I'm glad that they did the 34-hour test. I think that really does demonstrate robustness in the system. Having visited the facility and physically seen the changes and the additional capacity that they had planned on putting in, that we got it in, and now we're ready to go. So I'm very hopeful that we will see good results when we do wet dress.
Thank you. Our next question is from Manuel Manzanzi of Debate.
Hi, how are you? Manuel Manzanzi, covering the space program in Spanish. Actually, I think you answered my question before. Actually, I was going to ask you if the launch window that starts July 26 was out of the question, and obviously it is. We are moving to August. So, yeah, you basically answered. Maybe something that is coming out of my mind right now. Is CRS 25 being pushed to the 9th because the rollout now is the 5th?
Yeah, I can't answer that question. Captain, do you have that, or that wouldn't? I wouldn't. Manuel, it's a good question. I don't track that. We'd have to probably get back to you on that.
Yeah, we were. Hey, Tom, this is Cliff. I would just say when we looked at setting the roll date, we were working around their dates. They were originally scheduled, I believe, on the 7th, and I believe that change just occurred today. So I don't believe us rolling on the 5th, 6th impacted that date.
Yeah, and generally speaking, we want to roll as soon as we can. So yeah, I agree with Cliff. That's a good way to say it, Cliff.
Thank you. We have time for one final question, and that will be from Philip Sloss of NASA Spaceflight.
Thanks. Thanks for taking another question. I think this is actually sort of related to the gaseous nitrogen I think when you had some of the supply disruptions, you also have a converter compressor facility there. I think we'd heard that there are some modifications or some upgrades that might be scheduled in the June timeframe. Is the CCF going to be ready to support a wet dress rehearsal around the 19th? Thanks.
Yeah, Phil, let me take. We'll go offline and get you an answer. I want to make sure I get it exact right.
Hey,
go
Tom,
ahead.
yeah, I got information on that if you want me to go ahead.
Yeah, go ahead. I wasn't sure, so.
Yeah. So they're expecting to perform the repairs to a valve. There's a redundancy there, but that's why we were able to complete the air liquide testing. But the valve is expected to be repaired 6/1, no later than 6/3. And then they'll do a retest and exercise that valve and the cycling of that valve from 0 to 100% open. And we don't expect that to take any longer than June 4th to be complete.
All right. Thank you very much. Thank you all for joining us today. You can listen to a replay of this teleconference online by visiting the Media Resources tab at nasa.gov/Artemis-1 in about an hour. To follow along with the updates for the wet dress rehearsal test, please go to the Artemis blog at blogs.nasa.gov. Thank you again, and that will conclude our call.